Okay, here's another quiz prep video. This one is going to hopefully be number 3 through the end. So number 3, you wanted us to find the intercepts using the quadratic formula. So I'm going to go ahead and rewrite number 3 as 0 equals 7x squared minus 12x minus 2 with a equals 7, b equals negative 12, c equals negative 2. And again, I want to encourage you to work independently on this and use the video to check your work. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So I'm going to plug in negative b, that means opposite b. So 12 plus or minus square root of b squared. I always just go ahead and square it because we all know negative 12 squared is 144. Minus 4 times a times c. And hopefully you're noticing right here that you have a negative 4 times a positive 7 times a negative 2. You're going to end up with a positive product. And that's 2a on the bottom. So now I keep my negative b, my 12, plus and minus the square root of 144. It's going to be plus this, okay? negative 4 times 7 is negative 28, times negative 2 is positive 56, all over 28. That gives us 12 plus or minus the square root. And again, hopefully you're pausing so that you can do your work here, over 28. And I want to simplify my square root, so I'll do that off to the side here. Square root of 200. What's a perfect square? That's a factor of 200. If you think of our perfect square list, we have 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, and so on. So hopefully you see right there that 100 is a perfect square. That's a factor. So I'm going to make this square root of 100 times square root of 2, and that's going to get me 10 square root 2. So I'm going to replace this with a 10 square root 2. Now you're ready to write your answers. X equals 12 plus 10 root 2 over 28, and x equals 12 minus 10 root 2 over 28. You're supposed to write your answer 2 different ways. The ordered pair using the radical, 12 plus 10 root 2 over 28, comma 0. The other x-intercept is 12 minus 10 root 2 over 28, comma 0. Then you're supposed to put it in your calculator and find the answer rounded to the nearest tenth. For time, I'm not going to do that right now, but I'm going to remind you when you put it in the calculator to use parentheses around the numerator. Okay, so moving on to number 4, it says, what is the formula for the discriminant? Well, it is literally the radicand from the quadratic formula. So the discriminant formula is b squared minus 4ac. So for number 5 through 8, it says find the discriminant, state how many roots the equation has, and specify real or imaginary. Sketch a possible graph for each, and just show the concavity and number of roots. So number 5, a equals negative 2, b equals 12, c equals 5. So b squared minus 4ac is going to be 144 minus 4 times negative 2 times 5. Notice I'm not using a square root sign. The discriminant is just the radicand. That equals 144. Negative times a negative, that's positive 8 plus 5 So that is, times 5. Positive 8 times 5 is 40. So our discriminant is 184. That's a positive discriminant. When the discriminant is positive, you're going to have 2 real roots. And then it says sketch a possible graph. So on our possible graph, we're also going to be concave down because we have negative a. Concave down because a is negative. And so on our graph, we need to show that we're concave down and we have 2 real roots or 2 x-intercepts. If you want to go another extra step, you can see that you have a y-intercept of positive 5. You can also see that your vertex is going to be, this is all just extra, negative 12 over negative 2 times 2, which is going to be positive. So we're concave down, but we have a positive line of symmetry. So I could draw my graph like that. And that would be effective for number 5. For number 6, the equation given was y equals negative 2x squared plus 3x minus 5. A equals negative 2, B equals 3, C equals negative 5. The discriminant is b squared minus 4ac. And you're going to do b squared, which is 9, minus 4 times negative 2, because that's a, times negative 5, which is c. We have 3 negatives here. So when we do this, we're going to get 9. Negative 4 times negative 2 is positive 8, times negative 5 is negative 40. So we have a negative discriminant. Means we have no real roots. That means we have 2 imaginary roots. And that means no x-intercepts. We are concave down because a is negative. And if you wanted to draw this graph, at minimum, I would need to see concave down with no real roots, which means you're going to have to draw it with your vertex below the x-axis, right? If you draw it with the vertex here and you go concave down, you're going to get roots. So you don't want to do that. And then if you wanted to do a little extra, negative b over 2a to see where your line of symmetry is going to be, negative 3 over 2 times negative 2, that would give us a positive line of symmetry, which would put the line of symmetry over here. And we have a y-intercept of negative 5, so that would work also. Going back to the last one, I realized I made an error here. Oh, no, I didn't. I was perfect. Okay, going on to number 7. Here we have y equals 10x squared plus 15x minus 6. A equals 10, B equals 15, C equals negative 6. Discriminant. B squared, 225, minus 4 times 10 times negative 6. 225 plus negative 40 times 6. Negative 40 times negative 6 is positive 240. That would equal 465. That is a positive discriminant, so we're going to have 2 real roots. That means 2 x-intercepts. In this case, we are concave up because a is 10. It's because a is positive. If we want to sketch a graph on this, it it would be enough for you to draw a concave up graph that showed me 2 real roots. If you want to do a little bit extra, you have a y-intercept of -6. Your line of symmetry would be -15, that's negative b over 2a, which is over positive 20. So you would have a negative line of symmetry, so it would be over here somewhere. And you could draw it from there. Here's my concave up with 2 real roots. And number 8, we have 16 squared minus 8x plus 1. So I'm just going to 16. A equals 16, B equals -8, and C equals 1. So I'm going to do the discriminant, b squared minus 4ac. B squared, -8 times -8 is 64, minus 4. A is 16, C is 1. 4 times 16, or -4 times positive 16 is -64, times positive 1 is -64. 64 minus 64 equals 0. So this is the different situation. When I have a discriminant of 0, I have 1 real root. And if you remember, your handout called it a double root. I told you that it was 1 real root with multiplicity 2. Which you don't really need to know for this school year, but it is cool to say. What that means is if you factored this, you would actually get the same answer twice. And I just happen to know this one. If you factor it, you get 4x minus 1 times 4x minus 1 equals 0. So you can see you're going to get the same answer, right? You would do 4x minus 1 equals 0. And so what you end up getting, if you were to work all this out, which you don't have to do, I just wanted to show you. If you were to do all this work, you would get for both of these that the root was positive 1/4. So we only have 1 real root, multiplicity 2. We are concave up because A is positive. So to sketch your graph, if we're concave up and we only have 1 real root, it means my vertex must be sitting right on the x-axis. Want to see where our line of symmetry is? -b over 2a, that would be 8 over 16, or 8 over 32, so -b over 2 times 16. 8 over 32, that's positive. So if I wanted, I could draw it in quadrant 1. Notice I have 1 root and I'm concave up. Again, as long as your graph shows me 1 root and concave up, I'm not going to grade you on whether you have it in the proper quadrant, quadrant 1 or quadrant 2. Because what I'm looking for on these is that you know how to draw a parabola that is concave up with 1 real root. Okay, number 9, find the solution. So for number 9, we are to solve for x, because find the solution means solve for x. In fact, that's all we have to do, solve for x. So let's add 2 to both sides. By the way, did you notice there are no linear terms? I have an x squared, but I don't have anything that has a number and an x, like a bx. That does not exist on this problem, which means we just solve for x as usual. -110 plus 2 is -108. That's 3x squared. Remember, please, here, you must divide next. The square rooting is the last step. x squared equals negative 36. Oh, I'm going to get an imaginary answer, aren't I? So now I'm going to square root both sides because a square root is the inverse of squaring. And then I remember that rule that says if I square root a variable, I must also put a plus or minus on the other side. So x equals plus and minus square root of negative 36. What's the square root of negative 36? Well, it is square root of negative 1 times square root of 36. Square root of negative 1 is I. Square root of 36 is 6. So we're going to write it as plus and minus 6i. And let's write that two ways. X equals 6i. X equals negative 6i. Those are your two solutions to this problem. And finally, for the last ones that talk about simplifying square roots, the first one you have is the square root of negative 64. That equals the square root of negative 1 times the square root of 64. This is I, and this is 8, so our answer is 8i. The following question is the square root of negative 112. So you're going to look for the, well, you know you have a negative 1. Then you're going to see if 112 has any factors from our perfect square list, which is 4, 9, 16, 25, 36, 49, 64, 81, 100. So 112, I mean, 4 looks like a good candidate. So if I do 112 divided by 4, I get 28. So I wonder if 16 is going to work. I know that 16 times 5 is 80. I can do 16 times 6 and get 96. So I'm going to try 16 times 7, and that does work. So this is square root of 16 times square root of 7. That's going to give me I times 4 times root 7. I'm going to rewrite that as 4i square root 7. Square root of 108. I'm going to look for any perfect squares in there. 4 does go into 108. In fact, 4 goes in 27 times. And you know what I notice about 27? 27 can be split down some more. So let me show you a slightly different way to handle this one. So this is square root of 4 times square root of 27. Why don't I break 27 into square root of 9 times square root of 3? And then I might just want to check, does 4 times 9 times 3 equal 108? And if you do the math, it does. It works out. So now I can say that this is 2 times 3 times square root of 3. That equals 6 square root of 3. You know what that tells me? That I also could have done square root of 36 times square root of 3. That would get me 6 square root of 3. That would have been another way to do it if I had realized that 36 was a factor of 108. Good luck on your quiz.